which is just missing Jenny and Wendy. All right. Here we go. Good afternoon, everybody. Big crowd today. Wow, double-sized group. This is awesome. All right. Just a reminder that the best steel doesn't always shine the brightest. Okay, we don't always have to be the brightest to be the best. There's other ways to be the best. Okay, steel is really good at being strong, tough, all right? Flexible, actually. A lot of people don't really think of that, but it's very important that springs can bend a little bit when necessary. So all of these other properties contribute to being pretty darn awesome. So think about that sometime. All right, today we're going to do some pretty awesome things. We're going to talk about the test. Yay! Everybody's so excited, right? Yes, finally, I get to prove that I know stuff. Okay, so today we're going to go through the answers to the review. But before we dive into that, let me talk about what to expect with regards to this test. 2 parts. First part Wednesday, second part Friday. On Wednesday, you will take the written portion of the test. And that section looks a lot like the end of the review, these questions. So there will definitely be a question for you to think about and explain your answer using logical thinking, not necessarily a proof, as it were. And there will be another one where you're definitely rewriting an argument in symbolic form and justifying each step as you go along. Right? So pay attention to those 2 types of questions. The rest of the questions will appear in some form or another on Friday. All right, so that's the split. And of course, Friday's section will be significantly shorter than the rest of this. I don't need to give you, 6 different questions of the same type. There will just be 1 per idea on the test. It will be much shorter. I'm aiming for around 10 or maybe 12 questions at most. I haven't finalized the list yet. Anyways, so on Wednesday, I will post to Google Classroom the test as a Google document. You will log on to Zoom at the scheduled class time. All color groups are required to attend. That includes you guys, even though you're already here today, because it is a timed assessment portion. You need to report in, work on that, and then it is due at the end of the class period. So you have until then to turn it in and submit it on Google Classroom. Right? You need to be on Zoom with your camera on the whole time so I can see that it's you and only you working on this, that you have your notes. You're allowed to use your notes in paper format. Your machine, of course, will be dedicated to running the actual test. It will be in locked mode. You then have your notes, hard copies. If you've been keeping electronic copies, start printing them off now so you have them available. Right? If for whatever reason tomorrow you have something else scheduled because you weren't anticipating needing to be in class, you have a dentist appointment or whatever, email me now. You must tell me by today in order to be excused from that, and we can set up an alternative time for you to finish that part of your test. Otherwise, it'll be late and there'll be point penalties, and you don't want that. Same deal with Friday. Friday, you will report in, scheduled class time. You'll be on Zoom the whole time. You'll have your camera on. Instead of a document, it'll be a Google form. There'll be some multiple choice. There'll be some short answer. And again, I will post it at the beginning of the period. It'll be due, turned in by the end of the period. Okay, so you will have just that. Friday is shorter, so it'll be 40 minutes to work on. That's why I'm going for only 10 or so questions. I think that about covered it. Any questions about the test itself? Yes. Well, I say written, but more like typed. If you would prefer to handwrite and upload that, I guess I could allow that. Haven't met somebody who would prefer that. Yeah. Yes. 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 Everybody, the same time that you showed up here, log into Zoom. Same as if it were online class. All right? Okay, other questions? No? All right, then let's begin. So, the review covers a little bit of everything we've talked about, including those types of math. This is taken straight from the video, different types of math. So you were to categorize the disciplines. Linear algebra is pure. Optimization is applied. Topology is pure math. Numerical analysis, that's applied. Cryptography, applied. Chaos theory, pure. Pretty much anything that ends in theory is probably going to be pure. Okay, group theory is pure. Statistics is in fact applied. Set theory is pure. Computer science, applied. Engineering, very applied. Combinatorics, pure. All right. Part 2. This is taken straight from the Math with Bad Drawings post about math class with a one-word definition for math classes. Algebra is the math of relationships. Geometry is space. Calculus is change. Trigonometry is position. Probability is uncertainty. Statistics is populations. And logic is truth. Any questions from those two sections? Okay, please stop and ask for additional explanation at any time. Otherwise, this is going to be a real short trip. Part 3, matching the mathematical practices. This one was possibly one of the trickiest questions on here, honestly. Because some of these, in practice, you use multiple practices at once. They're very similar in their thinking, right? Using structure and repeated reasoning, well, that's kind of the definition of structure if you think about it. So I wouldn't hold it against you if you had a couple of these switched up. If this appears on the test, it'll be a much clearer format. It'll be much more obvious which one it should be if you know what the list is. Okay? But making sense of problems and persevering in solving them is example 5. Reasoning abstractly is example 6. Constructing viable arguments is example 2. Modeling is 1. Using appropriate tools is 8. Attending to precision is 3. Looking for and using structure is 7. And repeated reasoning is 4. And these examples are taken straight from the official Common Core explanation of each mathematical practice. So, there you go. Any questions on this section? Okay then. Onward. Math Thinking Fundamentals. These are again taken straight from my playlist of videos. Quantity is the fundamental of size, amount, distance, and measurement. Shape is space and visual representation. Relationships is connections between ideas. Variables is substitution symbols and reasoning abstractly. And inverse is working backwards. Next section, inductive reasoning, finding the next terms in the sequence. I do apologize for this. I didn't look quite carefully enough when I screen capped this from the textbook, but they did a really poor job in printing this thing, and some of these blanks overlap the final number by a bit and kind of cover it up. This is supposed to be 1,000. This is actually a 13. You can kind of see half the 3 hiding back there. So if you actually had 1,000 and then 10,000, or you had negative 13 and then negative 17 as your answer because you didn't see this number here, especially this one. This one's almost entirely hidden. Right? That's also another 13, by the way. I would accept that. Okay? They screwed this one up. I do apologize. But here is the numbers they were looking for. Number 3 is just multiplying by 10 each time. 5 is a constant difference. 7, oh, this is a unique sequence. We're going to see this one show up a lot. This is the Fibonacci sequence, named after a famous Italian mathematician. It takes each pair of numbers and adds them to get the next term. So you take 1 plus 1 to get 2, and then 1 plus 2 makes 3, and then 2 plus 3 makes 5. Right? And it's really unique. It's not quite exponential, but it's not a constant variable. But it is a slow growth that gets bigger and bigger as it goes. And so it's really cool. You'll see these numbers show up a lot actually in nature. It's fascinating how like plants always come in groups of like 3, 5, and 8. Kind of cool. We'll see it again. Then we have, say 9 is fairly straightforward. Keep subtracting there. 4 is a little tricky. If you represent all of these as with a common denominator of 6, you can see we are just counting 1/6, then 2/6, and 3/6, and so on. Number 6 is the triangular numbers. Number 8 are the square numbers. 10 are the powers of 2. All good sets of numbers you should know. Learn to love those. Question. Okay, looking for like a general pattern. Can you always use the first number's denominator? I guess it kind of depends on what the fractions are doing. You need to have enough number sense to at least recognize that these values are getting larger. Like looking at this, 1/6. Okay, that's a small fraction. A half. Okay, I recognize a half. That's an easy one. I know what that is. That's definitely bigger than a 1/6. So the numbers are going up, right? They're getting larger, maybe. And if you notice, hey, wait, I can represent half as a number of 6ths. And so kind of look, and that might be something worth trying if they are constantly increasing. Then yes, your best bet for a common denominator is the first one because it'll be the smallest of fractions. And you'll just be accumulating that amount each time. So that's a fair strategy. But you need checking on, right? Because that might not be what they're doing. Good question. All right. The shapes. Here are my beautiful drawings. Number 11 has a 5-sided figure with all the diagonals connected. Number 12 is a giant rectangle of, let's see, 7 columns and 10 rows there. Should have switched that. Should be 10 by 7, just to make it format. Anyways, 13, we've got 4 rows of steps here. 14, here is my fractal branch. There you got one more layer of little bits on the end. 15, we get to the super duper Triforce, Sierpinski's triangle. And 16, there's 4 by 4 squares with circles in them. Okay, and then the question at the bottom. When you use inductive reasoning, you are generalizing from careful observation that something is probably true. When you use deductive reasoning, you're establishing that if a set of properties is accepted as true, something else must be true. You will definitely need to distinguish between those two on the test. Any questions on that page? No? All right, next section. True or false? Number 1, the disjunction. That was a fancy word for the or combination of P and Q is true whenever P is true and Q is false. So or means I only need one of them to check out. So as long as P is true, the whole thing is true. That's okay. Number 2, if the conditional if P then Q is true, then the conditional if not P then not Q is true. That's bogus. That's the inverse, right? I've kept the order the same, PQ, PQ, but negated both sides. That's the inverse statement. The inverse is not automatically true. If you wanted a true statement, you'd have to switch the order and negate, make the contrapositive. Number 3, I am older than 20 or younger than 30 is an example of an exclusive or. An exclusive or is when you cannot have both. It must be one or the other. That's not the case here. You can totally be both older than 20 and younger than 30. In fact, that's me. That's false. That's an inclusive order. Number 4, the converse of if P then Q is if Q then P. That's true. And number 5, if P then Q means P is necessary for Q. That is false. P is one way to get to Q. If I have P, then I can get to Q. But that doesn't mean that's required to get to Q. There could be some other independent way of getting there. P is not involved at all. You don't know. So that statement does not mean P is necessary for Q. It does, however, imply the opposite. It does mean that Q will be necessary for P. Think about the contrapositive. If I had not Q, then I don't have P, right? So it would be required to go the other way. All right. Questions on that section? Next section. Converse, inverse, and contrapositive all together here. All right. Starting with converse, that is switching the order. All right. So we started with if P, then not Q. I reversed them to say if not Q, then P. The inverse, I have negated both of them. So P becomes not P. Not Q becomes not Q, which is just Q. Same order. Contrapositive does both things. It reverses the order and negates both sides, so I get if Q, then not P. And you can see the statements for the rest of them there. Any questions on that section? No? I do think I have finally come up with a mnemonic to help remember which is converse and which is inverse. Now hear me out on here. Are any of you familiar with the Converse All-Stars like line of shoes? Are you familiar with that? Converse is a type of shoe. You've heard of them?
Yes.
Yes? Okay. Now, when it comes to shoes, the order is important, right? Because you don't want to put your left shoe on your right foot. That would not be comfortable, right? So which order they are, left and right, makes a difference. So if you think about converse is the one where I've switched the order. Converse is dealing with order because converse, like the shoes, the order matters. Switching them changes things up. Right? You don't want to switch left and right. That's the best I've got so far. All right, next section. 7, decide the truth value of each statement. Okay, we need the truth of each piece, and then we need to know how do they actually combine with what's given in the middle. So on this one, 4 plus 7 equals 11. That's true. 1 plus 5 equals 6. That's also true. And they're combined with an and. And is only true if both things are true, which is the case I have here. So the whole thing is true. B, 2 plus 5 equals 7. That's true. 4 plus 2 equals 8. That is false. This is a biconditional, which means a conditional that can go in either direction. So in order for the whole thing to be true, both directions must be true. And for a conditional to be true, you must have not broken any promises. That is to say, so long as you don't go from true to false, the whole thing is true. Unfortunately here, this means I can go from this true statement to that false statement. That's a broken promise. That means the whole thing is false. You have started with a true fact and you led me to lies. You are a failure. C. 3 times 5 equals 12. No, it doesn't. That's false. 2 times 6 equals 11. Also false. Or gives me a lot of freedom. I only need one of them to be true to get truth on the whole thing. However, both sides failed, so the whole thing is false. D, if 2 plus 3 equals 5, which it does, this is true so far, don't lead me astray, then 1 plus 2 equals 4. Oh, shoot. You let me down here. That is false. The whole thing is false. You led me from truth to failure. You have broken a promise. That we cannot abide. E, though. E says if 3 plus 4 equals 6, which it does not. So E is starting with a false premise. If pigs fly, then we can do whatever I want, right? It does not matter what's over here if that's true or false. You started with a falsehood. It's never going to happen. So the whole thing is true no matter what. Kind of mostly by default, just because you can't prove it's false. It said if. Well, that's never going to happen, so the rest doesn't matter. Might as well be true. Same with F. If 7 is even, which it's not, so that starts out false. From a false premise, I can conclude anything. So the conditional is true. Questions on that section? Yes? Confused by E? Yeah? But did this break a promise to you? Did this set you up and then let you down? No, it let you down in the first place, right? It was already bogus. And then it just gave you more nonsense. So it's like, all right, nonsense leads to nonsense. Yeah, that's typically how the world works. So the conditional is true, even though the premise, the hypothesis at the beginning was false. what I'm saying? Like, if pigs fly, then I can do whatever I want. Well, pigs don't fly, okay? But that doesn't mean that it negates the fact that if they did, then I could do whatever I want. Well, sure, that part's still true. You can't really argue with that conditional. But it's a valid conclusion, but it wouldn't be sound, right? Okay, thank you. Good question. Next section, they recommend using an Euler diagram. You don't have to. I have not included them here, but if anybody wants to see one, please let me know. We can draw it up real quick. A, some men are teachers. Sam Jones is a teacher. Therefore, Sam Jones is a man. No, invalid conclusion. We know they're a teacher, so they go in that category. And there's some overlap with some men are teachers. But we don't know if we're in the overlap section or not. We're just within the teacher category. Right? So we can't conclude anything more about Sam Jones. However, B is a totally valid argument. Gold is heavy. Nothing but gold will satisfy Amy. Hence, nothing that is light. Well, if it's light, it is by definition not heavy, right? And if it's not heavy, well, then it can't possibly be gold because all gold is heavy, right? So the gold is inside the heavy category, and we're not in that circle. So we're definitely not in the gold category, which means we're also not in the satisfying Amy category. Right? So that is a valid conclusion. Next up, C. No cats are dogs. Two separate categories. All poodles are dogs. Okay, poodles go in this bin. And so some of the poodles, maybe not all of them, but some of the poodles for sure are not cats. Well, yeah, because they will not end up in the cat category. Yeah, that's valid. I mean, I would do one better and I would say all poodles are not cats, but, doesn't make this one wrong. Just because a better argument exists. All right, finally, D. Some cows eat hay. All horses eat hay. Only cows and horses eat hay. Ooh, now that's getting really specific there. Frank eats hay. Now, if you know that only cows and horses can eat hay, nothing else, if it eats hay, it must be in the cow or horse category. So Frank must be a cow or a horse. They conclude, so Frank is a horse. That is invalid. I can get down to Frank is a cow or a horse, but I can't guarantee that he's a horse. Even though it says all of them eat hay, well, he could also still be a cow, right? That possibility doesn't break any of those rules. Okay. Questions there?
So it would have been valid if it says, so Frank is a horse or a cow?
Correct.
Okay. But then right there in the cat one, it says some poodles are not cats. But it says all poodles are dogs.
Right.
So then wouldn't it be invalid because it says some poodles are not cats? But up there it says all poodles are dogs?
Here, let's go ahead and draw the diagram here. If no cats are dogs, that means there exists cats, there exists dogs, and there is no overlap between them. And then if all the poodles are the dogs, then we have a circle entirely inside here where there are poodles, right? Mm-hmm. So there is no overlap between poodles outside of dogs. There's definitely no overlap between poodles and cats. So not only can you say some poodles, which would be some poodles. So let's pick a section of them. Some of these poodles in here. Not necessarily all of them. We're just talking about some of them. This category, right, that green circle, are not cats. That is true. Yes? we can say one better. We can say all the poodles are not cats. Just because they talk about some poodles not cats, this does not imply there are other poodles that are cats. Okay? Be very careful with that. Just because I talked about some poodles doesn't mean I'm saying the opposite about the other poodles.
Oh, okay.
It's like, how did the argument go on the internet? This one did the rounds a couple of years ago. Right? I used to be a teacher. I still am, but I used to too. Right? Sometimes that language, you assume, oh, you used to be a teacher. Does that mean you aren't now? No. I didn't say that. I made a statement about the past. It just so happens it continues to be true. I think I confused you with that one, didn't I? Think about it. I used to be a teacher. I still am, but I used to too. You're automatically assuming when I say used to, that means no longer am now. But it doesn't. I didn't say that. Right? You're putting words in my mouth. Right? You're assuming we're talking, oh, this means there's some other poodles that you didn't talk about that are cats? No, not the case. All right, any other questions there? Cool, let's go on. Number 12. Determine your own valid conclusion if possible. A says all polyhedra have edges. A tetrahedron is a polyhedron. Okay, if you are not thrown off by the Greek pluralization, polyhedra is plural for polyhedron, then this thing goes in that category. That category has this property. Right? You don't need to know anything else about those words to be able to make this conclusion. A tetrahedron has edges. Right? That is, in fact, a version of modus ponens. B has no valid conclusion. We know if it is 5 p.m., then it is quitting time at work. It is 4:15 p.m. Does that mean it's not quitting time at work? Nope, you don't know that. We don't know anything about 4:15. We don't know anything about the other times other than 5 p.m. 5 p.m. could be quitting time. 4:30 could also be a quitting time. 4:15 could also be quitting time. Anything, maybe it's anything after 4 o'clock is a quitting time. If you are still here, please go home. We don't know whether that's the case. We only know 5 o'clock exactly. 4:59, 5:01. If you wait until 5:01, too late, you missed your chance, you're stuck here all day now. We don't know. No valid conclusion there. Okay, questions on that guy? All right, now for the big one. This is actually pretty similar reasoning here. Coach Schwartz told his starting 5 Wednesday evening, if any of you don't come to practice tomorrow, then you won't play in Friday's game. Darlene is one of Coach Schwartz's starting 5. She came to practice on Thursday, but she did not play in Friday's game. Does that mean the coach broke his word to Darlene? How could he? Careful. What he promised was if you don't come to practice, then you won't play in Friday's game. What he did not say is if you come to practice, then you will play Friday's game. That would be the inverse, right? If I take out the knots, if you do take out the knot, come to practice, then you will take out the knot, play Friday's game. Negating both sides. The inverse is not automatically true. In order for him to have broken his promise, the inverse would have had to be true. Coming to practice guarantees you playing in the game. That's not what he said. He said this is one of possibly many paths to not playing, not come to practice. is that the only way to not play in Friday's game? Not at all. We could think of many reasons why someone would not play in Friday's game. Maybe she got sick. Maybe she broke her leg, right? Maybe they show up at the game, they see the other team and go, oh, they put in that guy. Okay, what's her name? Darlene, you sit out this one. We're going to put in somebody else who's a better matchup against that opponent, right? Very strategic kind of decision. That happens in sports, right? Plenty of reasons for not playing Friday's game. Doesn't mean he broke prone. What am I undoing here? I don't know. All right. I've also added here to conclude as such would be denying the antecedent. Right? Denying the antecedent is one of those logical fallacies where you're assuming the inverse. Deny the first bit. So I'm going to negate don't come to practice, so do come to practice, and assume that means the opposite of this. Right? That's the fallacy there. Okay. Any questions on 14? Okay. The last one. Translate the following argument into symbolic form and justify that the argument is valid. In order to justify an argument as valid, you must in fact justify every line of your argument. Every statement must have a reason why you know that statement is true. There's only 5 possible answers right now. Either it was given to you, it's a premise, so we're technically assuming that it's true for now, or one of our 4 laws of logic. So here's my translation. I call this first statement, 60 out of 104 majors at the local university require calculus, M. I called calculus as an important class to take in college, C. And I called high school students should take all the math necessary to enter a calculus class, H. Okay? So that means what they've presented here is, first statement, if M then C. Second sentence is effectively if C then H. Their third sentence is just to restate, in fact, M is true. That's my line 4, okay? Because what they have not written out is the combination of these two with law of syllogism, the condensed form, combining these 2 conditionals into only 1 conditional. Okay? And it's important that you do that step so that you can combine it with that single statement with modus ponens, right? The reason you can make that final, therefore H must be true, is by modus ponens with a conditional. But in order to get all the way to H from M, you have to have if M then H, which is a law of syllogism combination. So they didn't restate that in the paragraph, but we need to include it so that we're following all the steps. Unless you would rather, instead of law of syllogism for this guy, you'd want to M and M to C, modus ponens, and then conclude C as a separate statement. And then you can modus ponens C with C then H to get H. So you could do 2 steps of modus ponens instead of law of syllogism then modus ponens. There is an option there. But everything I have stated here has been backed up with a reason. Very clear reason, what I'm referring to, numbered lines, all that. So there's no way to get lost. Any questions on this guy? We will definitely have one of these tomorrow. And I realized earlier today that we never went over the answers for Logic Lesson 6. So I have put those together in a document, and I will be uploading that to Google Classroom here at the end of the day for you to go back and review that homework and study that tonight in preparation for tomorrow. Okay? That said, final call for questions. Yes? How I got number 11 and the shapes. Shape. This guy. All right. We are growing in size. Here I've connected 2 points. Here I've connected 3 points. Here I've connected 4 points. So in translating this to a numbers, is there a thing I can count on these shapes? Yes, there is. And that is points go 1, 2, 3, 4. And I've connected all of them. And they're somewhat arranged. You know, they didn't go in a straight line, so they are arranged as some kind of a polygon. So at 4 points, I get at best a 4-sided figure, but I then connect all the points possible to make all of the diagonals in. So then probably what I should do here is highlight those points on my drawing. Right, is 5 points here being connected. So what you end up with is a 5-sided figure with all the diagonals drawn in. Then it would look like a 6-sided figure, a hexagon with all the diagonals drawn in. Right? Just arrange 6 points on your paper and draw every line connecting each dot to every other dot possible. Right? Again, that's what the pattern appears to be. We don't know. Maybe there's some hidden rule that says, okay, limit only 2 diagonals. Or limit your drawing to only create triangles out of the spaces there, right? And then you'd be like, hey, wait, I got this like pentagon-shaped thing in the middle. Oh, that's no good, right? You got to leave one of those out, right? Could be the case. We don't know. That's why it's inductive reasoning. It's not guaranteed. But that seems to be the best case follow of the pattern so far. All right. Any other questions? No? All right, then we had, we've only got like 2 minutes left. So feel free to chill for 2 minutes.